This section, we're going to kind of review the first half of my circles unit. We're going to talk a lot about the parts of circles, the arcs that circles make, as well as the different angles that are in the circles. All right, so let's see if we can get through some of these different terms here. Given this circle over here, this is circle C. Remember, we name it based off the center. So our first one, we can just say is going to be C. Point C is the center of this circle. A radius, that goes from the center to the curve of the circle. So I see 3 radii here. We have CB, CA, and CD. All those start at the center, and they go out to the curve of the circle. So let's pick one. I say CB. And because that's a line segment, I'm going to put a line segment over it. A diameter, this is going to be, it goes through the center from one side to the other. And you notice there I messed up. I said side. Really, circles don't have sides. It's from one curve to the other curve of the circle. It's easy to say side, but it doesn't really have sides, right? So BD is going to be a diameter. Does this one have any other diameters? No, it doesn't. You could flip it around and say DB, but that's the same segment. So keep that in mind. A chord. All right, and the chord in this one's going to be any segment that goes, again, from not one side, but from one curve of the circle across to another curve. It touches the circle twice. And so a diameter would work, but let's see if we can pick a different one. I see 3 here. What about BA? That barely goes through. That would work. Or DA as well as BD. Those are all going to be chords. I'll do AD, maybe. AD is going to be a chord of this circle. A secant, this is going to go through the circle. So it's kind of like a chord, but it keeps going. It's a line. So when I write this one, it's going to have arrows above it. And if I did BA, this one, notice it goes through that circle. It touches it twice, and it keeps going in both directions forever because it is a line. So that's BA, or I'll say AB, I guess. I'll flip it around. And I'm going to put little arrows on my line above it to show that it is a line. A tangent, this is only going to touch the circle in one spot. So this one wouldn't work because it touches it at B and at A. The other line that I see only touches it at D, touches it exactly at once. In fact, I've given the analogy to my class before. If I were to kind of put this in 3 dimensions and say this is like a ball, and I were to rotate this a little bit, so this would be like a floor rolling across like a gym floor. The floor would be the tangent line in that case. The ball would be the circle, okay? So it's only touching the circle or only touching the floor in exactly one spot, and here that spot's going to be point D. Okay, but the whole line itself is the tangent. So this is going to be DE for the tangent line. And again, it's a line, so it's going to get arrows above it. The point of tangency is going to be the point where, again, that ball would hit the floor. Here, the line touches the circle. So that's going to be point D. So it's just a point, it's just a capital letter D. A central angle and an inscribed angle. These are the 2 angles that are kind of in the first half of this section on circles. And we do get into some more interesting type of angles and how they're used later on. But to start with here, a central angle, this is going to include the center as the vertex. So if I were to pick like this angle right there, this would be angle BCA. And that is a central angle, angle BCA. All right, let's look really quick. Is there another one? There's actually probably a few. What about ACD? That would be this angle right here. That would be a central angle. You can also have a flat angle, say BCD. All right, there's a few different ones, but we'll just go with BCA. An inscribed angle, this is going to be one where the vertex is on the circle, or like I said wrongly earlier, on the side of the circle, if you want to think of it that way. And so here, BCA would not work because its vertex is the center. I want one where the vertex is on the side. So if I were to kind of use the B and the A, but extend this out a little further, then it would be BDA, where this angle is that inscribed angle there. All right, so BDA. All right, then we get into some arcs. We have a minor arc, a major arc, and a minor arc, a semicircle, and a major arc. I put it in order from least to greatest because a minor arc is less than 180, a semicircle is exactly 180 degrees, and then a major arc is going to be more than 180 degrees. So how do we know? There's no degrees listed out here. How do I know if it's more or less than 180? Well, you want to look for diameters, okay? A diameter, if you think of a whole circle is 360 degrees, a diameter is going to cut that exactly in half. And if we can find one and see kind of where it starts and ends, we can go ahead and say that's going to be a semicircle. So I'm going to start with this one, actually, a semicircle. And I'm seeing that my only diameter here is BD. Right, remember we said that earlier, it's BD. And so you use 3 letters to indicate that this is a semicircle with an arc on the top. So it's going to start with a B, it's going to end with a D. And if I want to say maybe this bottom part here, this would be B, and I have to just pick one other point to show that it's going to be on this side, and that's going to be BAD. Bad, right? Arc BAD is going to be a semicircle, because again, that indicates this is 180 degrees as it goes from kind of one part of the diameter to the other, making up exactly half of that circle. Excuse me. Okay, minor arc has to be just something less than that. So if I think that BAD is 180 degrees, well, if I go a little bit less, let me start maybe at A and just go A to D, well, that's going to be less. And minor arcs use 2 letters. So I'll put maybe a 2 in parentheses here. Semicircles and major arcs use 3 letters to name those, because you have to know which way around the circle you're going with these. With a minor arc, if there's just 2, that's automatically saying it's going to be the short way around. Not the long way, but the short way around that circle. So this will be AD, arc AD like that. Just use 2 letters. Okay, a major arc, if I were to say the other way around, maybe from A to D this way, since that's more than 180, I need to have a 3rd letter in the middle. So I'd say ABD. That's what I'll use here. ABD. And that just shows me that I'm going to start at the A, I'm going to finish at the D, but I'm going to go this way, which will be more than 180, because B to D itself, that's 180. That's a diameter, a little bit more, gives me more than 180 degrees. All right, let's talk about some more parts of the circle. Another part of our circles unit at the beginning talked a lot about tangents. And here, these 2 problems deal with tangents. This one in particular says, is QR tangent to circle P? And we know that if something is tangent, it's going to be perpendicular to the radius. So I can check to see if this angle, I'll put a dotted line here, put a dotted box to see if this is going to be a right angle or not. And if we want to check that, we can use a Pythagorean theorem, right? My A squared plus my B squared, the 2 legs, should equal the C squared, the hypotenuse of that right triangle. If it's not equal, then that's not going to be tangent. Okay, so to check this, what I can do is take my A squared, which is 5. We'll go 5 squared plus the B squared, 12 squared. And then I did this one on purpose because this part right here is 8, but what is PR? What's all of it? Well, if you think that PQ is a radius, P to whatever this point would also be a radius. So therefore, this is 5. So to find PR, all of it, I would take 5 plus 8. And of course, that's going to be 13. So my C squared, A squared plus B squared equals C squared, is going to be 13 squared. And now I have 25 plus 144 equals 13 squared is 169. And is 25 plus 144 169? Yes, it is. And so since those equal each other, this is going to be tangent. Again, if I were to get a different number, maybe I got like 200 equals 169, then it would not be. But since these equal, I can go ahead and actually fill this in with a solid right angle there to show that that is, in fact, tangent. So if I could answer the question with just yes. All right, in this one, this gives us, again, tangents, because it tells us that of these radii here in circle Z, they are perpendicular to these 2 lines. So WX and XY. Now, it's asking the question over here, it says, what does XY equal? And if I want to figure that out, I first need to probably solve for X, and I can plug that back in to XY, and that's going to give me what XY is here. So because these are both tangents, as long as they come and meet at a similar point out somewhere outside of the circle, I can set these 2 parts equal to each other and solve. We're going to go 3x minus 7 equals 5x minus 19. And let's solve for x. I like to move my smallest x because it gives me a positive x value. It's going to cancel. Now I have negative 7 equals 2x minus 19. You can add 19 to both sides. And it's going to cancel over here. Negative 7 plus 19 is 12. You can think of that backwards. 19 minus 7 if that helps you out a little bit. So we get 12 equals 2x. And so x, if I divide by 2, x is going to be 6. Put that off to the side. X equals 6. Now, be careful you don't stop there. Remember, what was our question asking? It was asking for xy. Xy is this length here. So I got to plug in that 6 and then solve for this particular part. And that's going to give me what xy is. So 5 times 6, if I were to plug this in, again, I like to leave open spaces. And in that spot, I'm going to put the x of 6. 5 times 6 is 30. Minus 19 is what? Well, 30 minus 20 would be 10. So minus 1 less would be 11. So xy, I can say, instead of a question mark, is going to be 11. Now, if your question also asked for wx, you don't even have to do the math on that one. Remember, these two are congruent, this one and this one. So it would also be 11. And you could use that to help you find those. All right, let's try one more thing. All right, this last problem that we're going to do about circles, it says that we have circle D here, which means that D is the center. It says that AC is 6. So whenever you see kind of information, you want to mark up your picture as much as possible. AC, that's the line segment AC. If that is 6, let's see, I could put a 6 here, or because these are perpendicular, we have a property that says that these two chords are going to be the same length, and also it's going to cut them exactly in half. Right now, my picture might be slightly off because I free-handed it. But anyway, if this A to C is 6, each half would be 3. So I'm going to say 3 and 3. And that would also be true on the other side. This would be 3 and 3 as well. Right? And then whatever I get for the other ones there and there, those will also be the same. So I can put tick marks for when we get there. DC, let's see, DC. So I don't have that line drawn. I'm going to draw it in. D to C, it says, is 5. And if I want, I could do the other side, the DG. That'd be fine. But I'll leave it like this for now. It also says that the arc FG, that's this one over here, is 70. I have a degree symbol above it, 70 degrees. So that's on the outside. And just like earlier, when FG, since that's 6, and AC is also 6, that means that their arcs, their kind of respective arcs, are also going to be the same degrees. So 70 degrees here and 70 degrees over there. All right. And then AF, that's this top one, is going to be 140 degrees. 140 degrees like that. All right, so it's asking us to find the following. It has a bunch of stuff listed out here. We're going to get through all this and then we'll be done with this video. But let's see if it says AC. Well, AC, we know already, like we said, is going to be 70 degrees because the other side is as well. GC, however, this one, this minor arc, well, if all the circle adds up to be 360 degrees, I can take 360, subtract 70, subtract 140, and subtract 70. And I think altogether that's going to be 280. So 360 minus 280 is going to leave me with, I believe, 80 degrees for CG, or GC, I guess, either way. Oops, GC, I about wrote it out again. Not GC, I want 80 degrees. 80 degrees. Okay, the rest of these are all going to be segments, and it's going to talk about some angles at the bottom. BC, let's see, where is that? That's going to be line segment BC. That's this right here. Well, because this AC was 6, half of it is going to be 3. That's already marked up. I marked that up earlier on our picture. BD, that's this one. I may or may not have mentioned this in a previous video. You might have watched it or not. But there's such a thing called a 3, 4, 5 right triangle. It's one of the easiest a squared plus b squared equals c squared, kind of your Pythagorean theorem to do. Right? If I were to think 3 squared plus 4 squared equals 5 squared, a squared plus b squared equals c squared, this is going to be 9 plus 16 equals 25. And of course, 9 plus 16 does equal 25. So if you have two side lengths and one of them is 3 and the other one's a 5, you need a 4 for that missing part there. And because I have a tick mark, remember I said earlier, those are going to be the same. That would also be 4 on the other side. So BD is going to be 4, using a little bit of math. DE, like I just said, is going to also be 4. FG, well, FG, 3 plus 3 is going to be 6. We talked about that one earlier as well. So if you get your picture marked up, they go kind of fast. EG is 3. Again, we marked that up as well. Then it says to construct angle ADF. All right, ADF. is going to be up here. Maybe I'll use green marker. Angle ADF, just like that. And it says, what is the measure of angle ADF? Well, what kind of angle is it? We talked about this in the very first part of this video. That's a central angle because the vertex is the center. And we know that central angles have the same measure as their corresponding arc. And so this angle here is going to be the same. It's going to also be 140 degrees. So therefore, the measure of angle ADF is 140 degrees. All right, guys, hopefully this video on circles helped you out. If you're one of my students, I think you have a quiz coming up, so good luck on that. Otherwise, until next time, keep doing your math homework fast and accurately.